Welcome to all of you. Myself Dr. Neha Desai, Assistant Professor in Department of Chemistry, RBNB College, Sri Rampur. Now today we will discuss about the size exclusion chromatography. In the last lecture we have covered the principle as well as how you can determine the molecular mass of a component by using the size exclusion chromatography. After studying these 2 points, the next most important point from size exclusion chromatography is coupled size exclusion column. So what is the meaning of coupled size exclusion column? That is, there are two possibilities in case of size exclusion chromatography. That is, if you want to obtain a well resolved and well separated column, then sometimes using a single column is not enough. For size exclusion chromatography, you are using a porous column. And when you are using a single porous column, then sometime a well resolved and well separated graph is not obtained. So in order to improve the resolution power or the resolving power, here instead of using a single column, sometimes there is necessity to use one more column. So in order to increase the resolution power or the separating power, we are adding one more column. So when you use, instead of a single column, 2 or more than 2 columns, then it will provide you the higher pore volume, and higher pore volume, it will be helpful for the separation. So as a result of this, you will obtain a higher pore volume. So if you want to separate a mixture of 3 different components, suppose it is containing 3 components A, B and C, and if you want to analyze it, then what is the result? If you analyze it by using a single column, then you will get peak like this if you are using a one column. And if the same analysis is carrying out by using the 2 columns, then you will get the well resolved and well separated column. Hence, if you add one more column in the size exclusion chromatography, then addition of one more column, it will be helpful to increase the pore volume, and increase in the pore volume, it also increases the resolving power or the resolution of a chromatogram, and as a result of this, you will obtain a well resolved and well separated chromatogram in size exclusion chromatography. So this is known as coupled size exclusion, where instead of using a single column, you are using the 2 more column. Now whenever you are doing the coupled size exclusion chromatography, you can separate a series of different types of mixtures or different types of compounds by using the size exclusion chromatography. So this coupled size exclusion chromatography, it is beneficial in the range of about 4,000 to 20,000. So you can use it up to the 4,000 to 20,000 molecular weight. So if the molecular weight of a compound is in the range of 4,000 to the 20,000, then in that range you can use the coupled size exclusion chromatography. Now whenever you are using two columns, sometimes two or more than two columns are also used in case of coupled size exclusion chromatography. So what should be the difference in their size? So one column, it should be having the pore volume or a pore size differ by a factor of 10. That means when in coupled size exclusion chromatography you are using two columns, then the one column, it should be different than the another column by a separation factor of 10. That means the pore volume of one column, it should differ by at least 10 with the another column. So all this is about the coupled size exclusion chromatography. That means in coupled size exclusion chromatography, instead of using a single porous column, you will be using two columns or more than two columns. So increase in the number of columns, it will increase the pore volume, and as a result of increase in the pore volume, you will get a well resolved and well separated graph. So to improve the resolution of a chromatogram is the main purpose behind using the coupled size exclusion chromatography. Now the next point from this chapter is phase system. So whenever you are considering the liquid chromatography technique, the choice of a mobile phase as well as stationary phase plays a very important role. So in case of size exclusion chromatography also, you have to think about the three factors. The first one is the mobile phase, the second one is the stationary phase, and the third one is the sample. So as size exclusion chromatography is entirely different chromatographic technique as compared to the other techniques, because here you have to just consider about the molecular size as well as the molecular weight of the substance. You do not consider here about the interactions between the stationary phase and mobile phase. But whenever you are selecting a mobile phase and stationary phase for the size exclusion chromatography, the following factors should be considered. So the first one is the sample must be readily soluble in the mobile phase. This is the first condition. So this is the first, that is the sample that you want to analyze by using the size exclusion chromatography. It must be soluble in the mobile phase. This is the first requirement. Then another one is that the sample must not interact with the stationary phase. Then the third one, the mobile phase must not damage the stationary phase, or the mobile phase must not interact the stationary phase. So these are the three necessary conditions for the considering the phase system. That means the sample, it must be readily soluble in the mobile phase. Then the mobile phase, it should not interact with the stationary phase, and your sample, it should not interact with the stationary phase. If all these three conditions are completely satisfied, then size exclusion chromatography is considered as the free, simple and rapid technique for the separation of the components. Now along with this, you have to also think about the different types of solvents that you are using as a mobile phase in case of size exclusion chromatography. So the material or the solvent that you are using, it must be compatible with the substances that you want to analyze. So if your sample, it does not dissolve in the mobile phase of the material, then it may interact with the stationary phase, and so instead of getting sharp peaks and well resolved peaks, you will obtain some peaks due to impurity. So the sample, it should be completely soluble in the mobile phase. If it is not soluble, then it is definitely going to interact with the stationary phase, and these components may appear in your well developed chromatogram. Now as far as the stationary phase is concerned, the adsorption taking place on the stationary phase, and the most commonly used stationary phase, it is nothing but the silica gel and alumina again. So whenever you are thinking about the stationary phases, these two materials are widely used as a stationary phase. Now along with this, when you are dealing with the aqueous system, in order to prevent the tailing or in order to prevent the broadening of peaks in the chromatogram, sometimes the detergents are also added in size exclusion chromatography. In size exclusion chromatography, in order to prevent the growth of a fungus, sometimes fungicide is also added. So this is regarding the phase system in size exclusion chromatography. Though the interactions of the stationary phase and the mobile phase does not play an important role in the size exclusion chromatography, the choice of a stationary phase, mobile phase, and along with that the sample, it should not interact with the stationary phase. All these are the necessary conditions to carry out the experiment using the size exclusion chromatography. Now along with this, the stationary phase which is most widely used, it is the silica gel or alumina. Then along with it, we have to also think about the different types of solvents that you are using, and in order to prevent the growth of a fungus, we have to add here the fungicide. And if you want to carry out the experiment using the aqueous solution or the aqueous system, then at that time you will use the detergents in order to prevent the tailing and broadening of the pants. So this is all regarding the phase system in size exclusion chromatography. Now the last point from this chapter is the applications. So we will see what are the different applications of size exclusion chromatography. So size exclusion chromatography, which is also known as the molecular sieve chromatography, it is most widely used for the polymerization reactions. So this is the first application. The most important application of size exclusion chromatography is the molecular mass determination. Along with this, it is also used for the isolation and the preparation of the different types of proteins. It is also used for the characterization of the samples which are of biological origins. It is also used for the analysis of the synthetic polymers. Along with the analysis of the synthetic polymers, it is also used for the separation of the different complex mixtures. Size exclusion chromatography, it is also used for the analysis of the fruit juice. Along with this, it is also used for the analysis of the substances which are used as a stabilizer or a flavoring agent. So all these are the different applications of size exclusion chromatography, and the most important application is the analysis of the different types of polymers or to control the polymerization reaction, and it is also known as the molecular sieve chromatography. So here our size exclusion chromatography, this chapter ends. In the next lecture we will start with the affinity chromatography. Thank you.